Okay, today we will learn about ionic equilibrium and acid base equilibrium. You see, we already know from our junior class knowledge what is an electrolyte and what is a non-electrolyte. We know this from our junior classes. An electrolyte is a substance which breaks down in water into its composite ions. Like for example, NaCl breaks down as Na plus Cl minus. On the contrary, if you put C6H12O6 glucose in water, it will not break down into its ions, so it is a non-electrolyte. And as because inside an electrolyte, the Na plus and Cl minus are broken down and they are mobile or free to move around in the solution, the solution has the capacity to conduct electric current. Now, among electrolytes, if you understand, then no such thing will occur in any of the non-electrolytes. It will not be broken down into its constituent ions, so there will be no conduction of electrons, no conduction of electricity if a cathode and an anode is put, anode and a cathode is put, and there will be conduction of electricity here, because in normal solution, the one which was moving around randomly, due to application of potential difference, they will now be subjected to specific movement. The positive charges will move towards the cathode and the negative charges will move towards the anode. Hence, the circuit will be complete and overall one particular direction of flow of electric current will be observed in a solution of an electrolyte. However, a non-electrolyte, as because it doesn't break down any of its constituent ions, then there will be no conduction of electrons. Now, speaking of electrolytes, when we speak of electrolytes, speaking of electrolytes, when we speak of electrolytes, electrolytes can be broken down into two types: strong electrolytes and weak electrolytes. Strong electrolytes and weak electrolytes. electrolytes. Now, who are strong electrolytes? Who are weak electrolytes? One simple definition or one simple term which can explain strong electrolyte, weak electrolyte is that alpha, the degree of dissociation. The degree of dissociation of an electrolyte is alpha, and alpha is equals to number of dissociated or number of moles of dissociated ion, number of moles of dissociated molecules or dissociated number of moles of dissociated or number of moles dissociated of the compound divided by total number of moles. Now, if you notice here, this is not the ratio of the concentration, this is the ratio of the amount. That should be kept in mind. This is not the ratio of the concentration. It has nothing to do with the ratio of the concentration, or it has nothing to do with ratio. It is not the ratio of an active mass, the moles per liter. It is not like that. It is just simply the number of moles divided by the number of moles. Right? It will be unitless, and this is the degree of dissociation. Now, if the degree of dissociation is high, very high, then it is a strong electrolyte, because it indicates that most of the molecules or the number of moles you have dissolved in is getting dissociated. And if the degree of dissociation is low, it indicates that the number of moles you have dissociated or the substance is dissociated in the solution is low. Now, this can be understood very easily, because suppose for example, you have dissociated NaCl and you have also dissociated CH3COOH. Now, NaCl breaks down as Na plus and Cl minus, and CH3COO minus and H plus. So these are the two dissociated products of NaCl and CH3COOH respectively. And what we find is that if the alpha is very high for NaCl and the alpha is low for CH3COOH, the reason behind is that suppose you have dissociated 5 moles of NaCl, and among the 5 moles of the NaCl, most of the NaCl molecules will be dissociated in its aqueous solution, and hence the numerator will be very big, because it will be suppose out of 5, 4.9 moles are only getting dissociated. So 4.9 by 5. Imagine the value. Suppose 5 moles of CH3COOH is there, and out of 5 moles of CH3COOH, only 1.5 mole of CH3COOH is getting dissociated. So its fraction will be 4.9 divided by 5. Its alpha will be 1.5 divided by 5. So the numerator is already big. Right or wrong? So why the numerator is big? Because maximum of the molecules dissociated. This is the nature of the substance. This depends on the nature of the substance, which is going to get dissociated, which is not going to get dissociated properly. This is the nature of the substance. So, because it is the nature of the substance, now what happens is that alpha comes more for NaCl and alpha comes less for weak CH3COOH. So that is the main difference between the strong electrolyte and weak electrolyte. One has high alpha, or the degree of dissociation of a strong electrolyte is good or high, and the degree of dissociation of a weak electrolyte is low. The examples of strong and weak electrolyte are given, NaCl and others if you want. Strong electrolyte example is NaCl, H2SO4 and KNO3. These are strong electrolytes. And however, weak electrolytes example if you want, weak electrolytes examples are NH4OH, CH3COOH, NH4OH, CH3COOH, etc. These examples you need to keep in your mind for the better understanding of the chapter. Now, as I have said, that a strong electrolyte is completely ionized in the aqueous solution. Therefore, their ionization is represented by a single arrow. Now, the fact is this, that if you want to show the ionization, suppose for example, you want to show the ionization, as the degree of dissociation is very high and most of the molecules get dissociated, or almost all the molecules get dissociated, all the number of moles dissociated. When you write it down, it will be written down as NaCl breaks down as Na plus and Cl minus. But the same equation, if you have to write down for a weak electrolyte, like for example CH3COOH, then you have to put a double arrow and write CH3COO minus plus H plus. Now, why this discrimination? Why this discrimination? That in case of strong electrolyte you are giving a single arrow, and in case of weak electrolyte you are giving a double arrow. The reason is this, that as because this dissociation constant is dissociation constant, but as because its degree of dissociation is less, as because its degree of dissociation is less. That's why the number of molecules which have dissociated will also tend to come back to its original state. Why a particular solute or a particular substance which is dissociated in water gets dissociated? Why? What is the reason of getting dissociated? The reason of getting dissociated is that they are when they break down, the products they form, okay, if they are very stable, then it will remain in dissociated form. Try to get my point. When the products are formed, if they are very stable, then the dissociation will be good. Or everything in this world, I like to say this, everything in this world, every physical process, chemical process, physics, chemistry, math, biology, wherever you go, you can apply one theory in your mind or to the application of lot of problems, is that everything tends towards stability. Now, as because NaCl dissociates and Na plus and Cl minus ions are very stable in their condition, so they will tend towards stability. But as because, let me put a single arrow here. Now, if I put a single arrow, CH3COOH breaks down to CH3COO minus and H plus. Now, as big as CH3COOH breaks down to CH3COO minus and H plus, then what happens is that you see, as big as CH3COOH breaks down to CH3COO minus and H plus, then what happens is that these are not very stable. This tends to join back. Okay, as because these are not very stable. This is the reason why the dissociation constant is, degree of dissociation is low, because they try to form back, and if they are trying to form back due to non-stability or less stability of their ions, that's why they tend to form CH3COOH again. This is the reason why you should give double arrow. And as because reversible process exists, then this process or dissociation of weak electrolytes may go into or goes into equilibrium. However, this dissociation doesn't go into equilibrium because it is only a forward reaction. Is this clear to everybody? I hope it is clear. So that is the thing that I wanted to tell you. Now, moving forward with our discussion. I think everything is fine. Moving forward with our discussion. Now, suppose if you tell that they are going into equilibrium, then how should you write it then down? उठा दो. Now, how should you write them down? Suppose, for example, AB is a weak electrolyte. Suppose, for example, AB is a weak electrolyte and it is in aqueous phase and it is getting dissociated into A plus and B minus. Okay? It is getting dissociated into Sorry for the tone. Now, K for this, Kc, na? We used to say Kc. What is Kc? Name of Kc is?
Equilibrium constant.
So, in case of ionic, we say ionization constant. The Kc becomes Ki in case of ionic equilibria. So, we will tell it ionization constant. Ionization constant will be same formula, right? It will be the same formula, which is known as the ionization constant. Achha, do you think that dissociation and ionization are same thing? Do you think that dissociation and ionization are same thing? Dissociation and ionization are same thing? No, obviously the answer is clear no. But in most of the books or in all the books, we will take dissociation and ionization to be the same thing. Actually, the subtle difference between dissociation and ionization is that ionization is for suppose substances like HCl or CH3COOH, which do not have any electrovalent bond in them. The molecules HCl is more electronegative and hence pulls the bonded pair of electron towards itself and becomes electronegative, and the H plus becomes del positive and becomes negative and positive. And these, when put inside water, in the influence of the water, with the influence of the water, as because water is itself a polar molecule, this is water molecule, and with the influence of water, suppose for example you are writing down, so a water molecule comes from this side, another water molecule comes from this side, lots of water molecule it is surrounded with. Now already HCl's condition was, one thing that the waters are not there, already HCl's condition was that it pulls the bonded pair of electron towards itself. And when it pulls the bonded pair of electron towards itself, it becomes slightly delta negative and delta positive. Now imagine that this molecule has been put inside water. When it has been put inside water, then what is happening? This is slightly delta negative and this starts pulling the H plus, and this is slightly delta positive. It starts a force of attraction between Cl minus. Then the Cl minus will take away the entire bonded electron. Suppose HCl is there, entire bond को लेके Cl minus और H plus में break down हो जाएगा. आयनिक फॉर्म में नहीं था, लेकिन फिर भी आयनिक फॉर्म हुआ. So it is ionization. Ionization occurs for such type of compounds. But in case of NaCl, this type of compounds, Na plus and Cl minus is already existing. Inside NaCl, already the ions are existing in the crystal structure, right or wrong? When you dissolve NaCl, what happens is that in the crystals of the NaCl, the ions are there, that starts dissolving inside water. Okay, that starts breaking down from the crystal and dissolving in the crystal. Both are different, but the dissolution of both, or the solution of both, or the formation of ion of both inside water, the mechanism is different. The NaCl, if you see, it is in solid state, and in the solid state they remain in crystal lattice format. The crystal lattice form is like this: Na plus, Cl minus, then Na plus, then Cl minus, then Na plus. In this way, they form a network of structures which is three-dimensional. Are you getting my point? This is a crystal structure. From the crystal structure, the Na plus and Cl minus start going into the crystal structure is disturbed, and from the crystal structure, the Na plus and Cl association. And the formation of ions into the water is known as ionization. But however, invariably they are used as same term. Is this clear to you? Is this understood? Now moving more. Now we will learn, if you have understood up to this much. So now, one more thing. The Ki I have told, the Ki is equals to A, concentration of A plus B minus divided by the concentration of AB. The concentration of A plus B minus divided by the concentration of AB. Now, if you see that the A plus and B minus concentration is high, the dissociation constant or the ionization constant will also go up. So that means the Ki is great or big for strong electrolytes, because for strong electrolytes you will get this more. If the alpha is more, the Ki will be more. Right or wrong? But Ki is entirely different thing from alpha. You cannot confuse alpha and K. Remember, you cannot confuse alpha and K. Alpha is something else, K is something else. You cannot confuse it. Remember this. The alpha is equals to number of moles dissociated divided by total number of moles. The number of moles dissociated divided by the total number of moles, that is alpha, and K is concentration of A plus concentration of B minus divided by concentration of AB. Now the formula looks very different, so they are different. Now here K will have a unit depending on what are the powers of A minus and B minus, right or wrong, all these things. The K will have a unit. If there is no power, then K will not have unit. Alpha will never have a unit. But if the K has a power, suppose it is the 2, it is A, suppose the formula is A to B, then 2A plus will come now. Here or yes or wrong? So 2A plus will come, so here will be 2, so then there will be a unit. And the A plus B minus, this concentration are in mole per liter. But here it is just number of moles, it is just divided by number of moles. Means alpha gives you an idea that how many number of moles or how many molecules. Number of moles means it actually indicates how many molecules are there in the solution, right or wrong? It's simply expressed as moles, so that how much weight you have taken in respect to that, or how much mass of the substance you have taken. Moles का ये क्या है? Mass of the substance divided by molecular mass. So however, how much mass you have taken, with that respect कितना molecules है, because one mole contains 6.022 into 10 to the power 23. যেমন ধর এখান থেকে তুই জুপিটারে যাবি, তুই কি কিলোমিটারসে ক্যালকুলেট করবি না লাইট ইয়ার্সে ক্যালকুলেট করবি? নিশ্চয়ই লাইট ইয়ার্সে ক্যালকুলেট করবি। সেই জন্যই সবসময় তো এত मॉलिक्यूल है, इतना मॉलिक्यूल देके रखता है, तो नंबर ऑफ मॉलिक्यूल बाय नंबर ऑफ मॉलिक्यूल का नंबर लिख के तुम कैलकुलेशन कर पाएगा? नहीं कर पाएगा, टफ हो जाएगा। इसीलिए नंबर ऑफ मोल्स का इजाद किया गया है, राइट और रॉन्ग? फर्स्ट चैप्टर का बात बता रहा हूँ, राइट? सो इस ये हमको सिर्फ इतना आइडिया देता है कि कितना मॉलिक्यूल डिसोसिएट किया है विद रिस्पेक्ट टू कितना मॉलिक्यूल तुमने डिसॉल्व किया है, राइट और रॉन्ग? और ये हमको आइडिया देता है कि अगर एक सॉल्ट अपने दिया है, ठीक है, तो कितना कॉन्सेंट्रेशन ऑफ A प्लस और B माइनस फॉर्म हुआ है, दोनों का कितना कॉन्सेंट्रेशन फॉर्म हुआ है डिवाइडेड बाय द इंटर कॉन्सेंट्रेशन. इट फील्स एज इफ बोथ आर सेम थिंग, right or wrong, but both are not same, their units are different. K is a dimensionless quantity. Okay, so is alpha. Is this clear to you? The difference of both is clear to you. However, if you see in terms of Ki, it is for strong electrolyte. If it is for strong electrolyte, this A plus and formation of A plus and B minus will be in large concentration, because most of the amount of the concentration present in per liter of the solution will be broken down. Okay, and the concentration will be large, and this concentration will be same only, means whatever you have taken. But if it is a weak electrolyte, then this concentrations will be less. So Ki numerator large means Ki will be large for strong electrolytes, and ionization constant will be